I think we are live. Let me check if everything works with the sound. We already have 25 people waiting here, so should be good. Let me check. Awesome. Yeah, we're live. Thanks everybody for tuning in to this spontaneous episode today with John from Celestia. First of all, please let us know if the sound works, if everything is all right with that. It's always the most important thing. And yeah, I mean, this was supposed to be with Akash from Evmos, but we had to reschedule that. So I have John on here, which is a perfect timing because you guys just announced Cevmos, which is a new product that's being built in collaboration with the Evmos team. So John, I really appreciate jumping on so spontaneously. How is everything going? How are you?
I'm glad to be here. I'm doing well. How have you been?
I'm good. I mean, this week was crazy in the Cosmos ecosystem. A lot of things went down. Mainnets went live. We have our first meme coin now in the ecosystem. Lots of things.
The Shiba Inu, right? Or no,
Chihuahua. Yeah, Chihuahua.
Okay.
So yeah, a lot of things are happening. But I'm always also tracking what you guys are doing. And since I met Ismail and the Celestia team in Lisbon, I've also understood a little bit more what you do, but it's still very complex, right? Especially for the non-techie people out there, including myself, in terms of what data availability means, what rollups are, right? There's a lot of different variations of it, what scaling issues are these days in the crypto space. So I think this is going to be a very, very educational episode, and we already have a lot of people tuning in here. So yeah, I think before we jump into all these topics, maybe first of all, you can give us a little bit of context on your personal crypto journey. I see on Twitter it says ETH Maxi. So where does that come from? And basically just introducing yourself here real quick.
Sure. So I'm John Adler. I'm one of the co-founders of Celestia Labs, and we're developing the Celestia software. I guess Celestia full node software. We can start, I guess, with a journey, and then we can get to how I ended up with that line in my Twitter profile first, I guess, at the end. So my journey. So I kind of got introduced to crypto. I think it was around 2016. It may have been even slightly earlier though. I was doing my graduate studies at University of Toronto in formal verification of hardware circuits. And my grad school advisor at the time was really into this thing called Ethereum. And prior to that, he was also into Bitcoin and cryptocurrency stuff in general. And one fun picture that he likes showing his students is that, you know how when Mt. Gox happened back in the day, there was the guy with a sign, and he's like, give us back our Bitcoins and stuff. There's the one famous picture about the Mt. Gox situation that happened, and he actually took a selfie with that guy the day that it happened because he happened to be in Japan when Mt. Gox happened, so he has a selfie with that guy. Anyway, so he's been involved in cryptocurrencies for a while, and he kind of introduced his students to this thing called Ethereum back in the early days, like 2015 or so, 2016. And I kind of didn't really know much about cryptocurrencies at the time at all, because again, my research stuff was in a completely different field, essentially. But I had a general passing interest in compilers, and there happens to be a large overlap between compilers and the virtual machines that blockchains run, things like the EVM for Ethereum, Bitcoin is Bitcoin script, and so on. There's quite a bit of overlap in the concepts there. So I kind of, started looking into it, and the next thing you know, I was down the crypto rabbit hole like so many of us are. And the next thing you know, I'm just like, oh, I guess it's time for me to leave my graduate studies and go work in crypto full time. So I'm sure that has happened to quite a few other people out there. So I joined Consensus, I think, towards the end of 2018. I think that's towards the end of 2018, to do just general layer 2 scalability research. I happened to join a team that was that had, like, they just allocated one guy and said, okay, this one guy can just do research. So I happened to join Consensus at both at a very opportune position and at a very opportune time in the layer 2 scaling research space. because people around that time were very excited about this thing called plasma, because Joseph Poon and Vitalik Buterin co-authored, the plasma white paper that described some general high-level techniques, some general, principles and properties of plasma constructions, and people were trying to then devise concrete protocols that would kind of satisfy these properties. There's Plasma MVP, Plasma Cash, Plasma Debit, Plasma Credit, Plasma Gluon, Plasma whatever. I don't even know. There was like a million flavors. You know the tree of flavors of plasma and stuff, right? There was a bunch of people trying to implement concrete instantiations of this protocol that satisfy these properties, with varying degrees of success. And I was basically given free reign to just do general research on layer 2 scalability stuff. While I was there, about a month after I joined Consensus, Mustafa Al-Bassam, who is also one of the co-founders of the Celestia Labs, published a paper formalizing fraud and data availability proofs, co-authored with Vitalik Buterin. This was like in October after I joined, so I think it was 2018, but whatever. And this really piqued my interest. This is like the formative paper of my entire time at Consensus, because I saw that, and prior to this, I had always assumed that fraud proofs weren't possible, because I'd kind of listened to what the Bitcoin core developers were saying. You can't have this thing called a fraud proof. It's not possible. And then Mustafa comes along and publishes a paper that formalizes not only is it possible, but here's a formal description of it, along with all the security assumptions and everything, and here's how it works. Now, are you familiar with what a fraud proof is, or should I maybe describe it?
I think we should get into those things, but maybe you can continue just with your journey, and then later we can get into those technical terms, and then also what data availability actually means in those things.
Okay, sounds good. Then I'll continue on with the journey.
Yeah.
So after this, a few months later, Mustafa published a paper titled Lazy Ledger. There was some subtitles. Embarrassingly enough, I can't remember the subtitle. It was Lazy Ledger at the time, which described a blockchain that was lazy, a blockchain that didn't execute transactions, but just ordered them and made them available. And again, like you said, we'll cover what that means in a bit.
Yeah.
But I was so interested in this because it happened to be in line with what I was researching and what I was thinking about this entire time since I had seen his first paper in fraud and data availability proofs. This is kind of the general research direction I had been taking throughout the entire rest of my time at Consensus. And he published the paper in Archive, which is like this site where you can publish academic papers and stuff. And then he also published a summary of it in more plain English and more accessible form on the ETH Research forum. And I saw that he posted this like a few minutes after he had posted on ETH Research, because back in the day I would go on ETH Research quite often because it was quite active because of all the plasma talk and all that stuff. Right, plasma was the talk of the town. Everyone was super active on ETH Research. Now it's basically a graveyard because there's not really much innovation happening coming from the Ethereum space. So not much gets posted on ETH Research. But regardless, at the time there was a lot happening, so I was on there all the time. I see his post minutes after it's posted. I skimmed through it. I skimmed through the paper, and I'm like, "Oh shit, this is amazing!" And I knew exactly what it was about because, like I said, I had been thinking about this line of research this entire time for months now. And I go check his Twitter, and I see that he's active on Twitter, but he hasn't posted that he posted this paper or published. He hasn't posted about the paper being published, and he hasn't posted about the post being published. So I'm like, well, this guy's active on Twitter. I don't know why he's not posting this, but maybe he's just not going to. So I go and I start writing a tweet, and I say, oh wow, here's this amazing thing, this Lazy Ledger thing, right? Here's shared on ETH Research, right? So I go, I tweet it out, I click send, and then I see in my Twitter feed that I scroll to the top, so I see my new tweet, and right under mine, just like a few seconds before I sent my tweet, I see Mustafa was also tweeting about it. So basically, while I was writing my tweet, he was also writing his tweet about his forum post. That's kind of the funny story, I think, of how we kind of started interacting around this Lazy Ledger idea, and we had other interactions throughout the months on general Ethereum and scalability research topics. And then after that, I think in early 2019, or maybe day 20. Whatever. COVID has ruined my sense of time. I don't even know years anymore. Whatever. Some time ago, Mustafa reached out and asked me if I wanted to co-found, at the time, I guess, Lazy Ledger Labs, and essentially start this project. And I was like, hell yes. Now, I guess how I have that thing in my Twitter bio that says I'm the biggest ETH maxi on Twitter. This is completely unrelated to any of this journey. It was basically just I was shitposting with Udi. If you're familiar with Udi, the guy who's Udi Wertheimer, who's been an outspoken and vocal critic of Bitcoin maximalism, or just maximalism in general. He's a buddy of mine, and then he kind of was making fun of me, calling me an ETH maxi. So I just put that in my bio. That's basically it.
Interesting. Yeah, that's a very cool journey. It sounds like it's been destiny with Mustafa and the whole Celestia journey, how it came together. I don't know, but maybe before we jump into all these things, one thing that interests me, because it seems like that you have been active also in various communities, especially also within the Ethereum community. So maybe you can share your thoughts on how you view Bitcoin and Ethereum today, in terms of like positioning within the broader blockchain revolution, and also like so that we can get a sense how you view the blockchain industry as a whole evolving, and what you think is the most important thing that needs to be resolved for blockchain and cryptocurrencies to gain true mass adoption.
Yeah, so that's a very low. There's a lot of things. There's a lot of sub questions in that question. Let's see if we can break it down. So Bitcoin and Ethereum they have a lot of, I don't know if legacy is the right expression, but they have a lot of history, right? Bitcoin was the first decentralized cryptocurrency under particular threat models. Ethereum was the first decentralized cryptocurrency that offered, richly stateful smart contracts where you could have loops and storage and all this other stuff. So in that sense, I don't know what the future holds for these networks and the assets that are on top of them. Lots of people like to say, lots of people in the Ethereum space like to say, that Bitcoin will get flipped by something technologically better, such as Ethereum. Maybe Ethereum gets flipped by something technologically better eventually, and it repeats. My personal opinion is that we'll see what happened to things like Blockbuster versus Netflix, or what happened to Sears versus Amazon. Right? It's if you can't keep up with technological innovation, eventually you'll get supplanted, and that's not a bad thing. Right? It's not a bad thing that these networks get supplanted. And we have seen that once they get to a certain size, they tend to ossify slowly. Bitcoin is kind of the prime example. They've had literally 2 almost irrelevant upgrades in the past 5 years or something. 5 years, right? They had SegWit back in 2017, I think, and they had Taproot just recently, like a few months ago, and literally 0 people care about Taproot. SegWit was a block size increase from 1 megabyte to effectively 2.5 megabytes, right? And that's it. It didn't enable anything really. No one uses the Lightning Network, so it's essentially ossified. There's no changes happening at Bitcoin. Ethereum seems to be traveling down the same path. If you've listened in on any all core dev calls and so on, even the simplest changes I don't know, decreasing some parameter that is obviously imbalanced, or adding a single instruction gets bike shedded for 2-3 years, and that wastes thousands of hours of man hours. Core development on the Ethereum protocol has slowed down to a glacial pace, and they don't seem to be keen on breaking this inertia of slowing down. ETH2 was supposed to be a time where the state machine that people would use in the Ethereum ecosystem would be a breaking change. They would use EWASM or something. But that breaking change never happened. They said, well, I guess we'll just inherit the EVM with all its backwards compatibility baggage, and now everyone just has to fully validate it if you're running an ETH2 node. which was kind of not what they wanted to do, because that's not great. Right, so that protocol development for Ethereum has also slowed down. I imagine in the long term, if I had to make a prediction, it's Bitcoin is going to get supplanted by Ethereum or something else. It depends how long Bitcoin can resist, really. And Ethereum will be supplanted by something else, also depending on how long it can resist. And just like all technological innovation, I think this will continue forever. That I don't think there'll be an end state where we'll say this is the one blockchain and the final blockchain, and it's the only thing that will exist and no one can ever beat it. I don't think that will ever happen. And one of the reasons is not because and one of the reasons that I think that the cycle will repeat is because of how easy it is, and this is a good thing, of how easy it is to essentially start up a new chain, to start up a new product, a new project. And this is different than, for instance, let's say you wanted to compete with Walmart, right? If you wanted to compete with Walmart, you would have to put in potentially like ridiculous amounts of capital. You would have to fight against regulations. You would have to have lawyers to incorporate in various, states and jurisdictions. It would be an astronomical undertaking to compete with the likes of Walmart, right, nowadays, or the likes of Amazon. If you wanted to compete with the likes of Bitcoin, you can do it in your garage with a few friends. If you really have the smarts and the drive and the motivation, you don't need a huge amount of capital to build nice blockchains, right? To build technologically superior blockchains or blockchains that have better mechanisms for social coordination and stuff. It's the barrier to entry is so low, and this is good because it allows rapid experimentation. It allows us to get better, to get better blockchains faster, to iterate faster. Did that answer your question? I think.
No, that's exactly what I wanted to get down to, like to just have a kind of like an insight on how you view the whole industry. And I think we got a lot of very, very useful insights. Just one question regarding your takes on Ethereum, because it seems to be various things that kind of like slow down the development there, right? I think a lot of people have been really excited about the ETH2 merge and kind of like this transition coming to life, but it sounds from what you're saying that there's still a long list of things that needs to be done and resolved to get to this point, right? So do you think that this slowdown is because there's too many stakeholders within Ethereum, that it's already too big kind of like to move, similar to maybe what Bitcoin would slow down the development on Bitcoin? Or do you think it's just because there have been other breakthroughs in terms of innovation, also in the proof of stake front and interoperability, that developers and people are just more interested to rather build their own things? What do you think are the reasons for the slowdown in the development on Ethereum?
So we should clarify that there's a difference between the consensus protocol of the chain and the execution environment that it runs, right? So Ethereum, for instance, currently it uses Nakamoto consensus with proof of work to build new blocks. And it uses the Ethereum virtual machine to actually validate individual transactions. After the merge, it's going to use Gasper with proof of stake for producing blocks, and it'll use still the same Ethereum virtual machine for processing transactions. The merge happening doesn't really change anything about the Ethereum virtual machine and its limitations and the associated downsides with it. Sure, it introduces, this new consensus protocol that will presumably allow you to run your blockchain with much less energy requirements, which is good. But beyond that, it doesn't fundamentally allow things like Ethereum to process more transactions per second, or it doesn't allow Ethereum to process transactions in different, better ways. For instance, an old colleague of mine at Quilt is working on EIP 3074, if I remember well, which essentially is kind of like a pseudo account abstraction mechanism. It allows you to execute arbitrary code prior to a transaction being valid or not. And this arbitrary code could include atomic calls to multiple contracts. And ignoring all the techno babble that I just said, just know that EIP 3074 would allow you to do in a single transaction an approve, then a transfer from for tokens. Because you know how currently you have to do two transactions. You first have to do an approve to approve your tokens to a contract, then you have to do a transfer from to actually transfer your tokens. With EIP 3074, you could do that in one transaction, an approve and a transfer from atomically. So there's a bunch of innovations like this happening. Wait, I got lost. What was your question again?
Regarding the slowdown on the Ethereum.
The slowdown. Okay, yeah. So,
yeah.
So the merge will change the consensus protocol to gas per through of stake, but it won't change the execution environment. And fundamentally, the execution environment, for example, in Bitcoin, the execution environment is Bitcoin script, and they have some UTXOs. The consensus protocol is Nakamoto consensus. Ethereum uses Nakamoto consensus, but uses the Ethereum virtual machine for execution. And that's why it's so interesting. Not because it uses the same consensus protocol or even a different one. It's just so exciting, and it has so many new applications because it uses a different execution environment, because it uses a different virtual machine. And if you change the consensus protocol to Gasper, but keep the virtual machine the same, you're not really doing anything, ultimately. Like, you're cutting, I guess, the cost of running the consensus protocol, so I guess more ether is going to be burned. People are excited for a number go up. But fundamentally, you're not fixing any of Ethereum's problems, because the energy burn it's a minor thing in the grand scheme of things, in terms of what Ethereum's issues are. So that's kind of the core, is that you want to upgrade the execution environment, not the consensus protocol. Okay, so now the question is, why is it so slow? That's a very hard question. I don't actually know if I have a good answer to that, because governance is a hard problem. You know, the way Ethereum governance works is nebulous. You have the all-core devs, you have many different stakeholder parties, you have coin holders, you have exchanges, you have application developers, you have wallet developers. They all have to coordinate. Maybe it's because there's a large number of them. Maybe it's because some parties wield more power and don't want to be woken up in the middle of the night because the protocol changed and they have to fix the bugs if there's bugs in there. There's various considerations, and I don't know if I have a good answer for why things slow down. I feel like that's very unsatisfactory. That's a very unsatisfactory answer.
No. I really appreciate you pointing out the difference between the execution layer and the smart contract layer. And I think that's also a perfect starting point to really understand what Celestia aims to do with providing data availability solution to make this faster. But maybe we can talk a little bit about your views on Cosmos, because Celestia is also powered by Tenement, which is a consensus algorithm, right? So maybe you can share some views that you have on Cosmos technology, where you also view Celestia fitting into that, also kind of like what role Celestia then plays within the broader Cosmos ecosystem.
Yeah, sure. So so there's two kind of points here. The first being Cosmos, the second being Tendermint. I guess we can cover Cosmos first. So Cosmos zones. So the Cosmos operates where they have presumably one or more hubs that negotiate communication between zones, but the hubs are optional, and they have zones, where zones are just blockchains. Like, they call them zones, but really they're just blockchains. They're essentially completely separate blockchains that follow certain nice standards that allow for easier interoperability, because they follow standards. They can use things like IBC, I think, inter-blockchain communication protocol. They can use IBC for communication between different zones just because the zones follow standards. But beyond that, they're just layer 1 blockchains, completely separate to each other. And as we know from building bridges between chains, building bridges is not easy. It's especially not easy if they don't follow the same standard, but if they do, even if they do follow the same standard, the issue isn't the fact that they use different encoding schemes or different ways of signing over transactions or different elliptic curves to generate signatures. That's not the real problem. The real problem is fundamentally that if you have two blockchains that don't have the same security, in other words, one of them can be reorged or its history can be changed without affecting the other one, then that bridge fundamentally is exploitable. Right? Because you can always reorg one chain and essentially steal money from the bridge. You're just stealing money, and it doesn't really cost you anything. So this is very dangerous. And this is where solutions like Celestia come in. Because you can use... Maybe I should explain what Celestia is. So Celestia is a blockchain. It's a layer 1 blockchain. And as you alluded to earlier, it does something interesting with its virtual machine, with its execution environment, that no other blockchain does. And specifically what it does is, rather than having an execution environment that actually validates transactions to ensure they're valid, the Celestia virtual machine doesn't validate transactions at all. It does not care what people's account balances are. It doesn't care what the UTXO set is. It doesn't care about the Uniswap contract or any other contract. All it does is it takes those zeros and ones that are in the transaction data and it puts them in a block. And it says, okay, here's a block. The block has zeros and ones in this sequence. And I'm not going to execute those transactions. I'm just going to put them in the block. Now, what you can do is once you have, like Celestia will run a consensus protocol over these blocks, like Tendermint consensus, like you said. And once you have these zeros and ones and a nice ordering from the consensus protocol, you can run applications on top of it, where the applications will kind of pull up some zeros and ones. They'll pull out some subset of the blocks and run some virtual machine over these transactions. For example, you could imagine that you would just imagine you taking entire Bitcoin blocks, like the entire Bitcoin block, and you just put it on Celestia. Just put every single Bitcoin block, header included, you just put it all on Celestia. Then, and there could be other applications too, like Ethereum, you could run Solana, you could run the Cosmos Hub, Gaia, or whatever. You could run Chihuahua Chain if you wanted to. You could run a bunch of different applications. So the Bitcoin application would now go to the Celestia blockchain and say, okay, give me all the zeros and ones for my Bitcoin application. It would get back those Bitcoin application blocks and run the Bitcoin full node software and validate the transactions. And that's all Celestia is that imagine you take blocks from other blockchains and you put them there. Now, we said before that this notion of security between two chains is that if you can reorg one chain but not the other, then you can steal money from the bridge. But if you post all the blocks to Celestia, you can't reorg one chain unless you reorg Celestia itself. But by reorging Celestia, you change the history of all the applications. In other words, you no longer have the issue where someone can steal money from one side of the bridge at essentially no cost, because you would have to reorg everything, which means now reorgs affect everything. And this is what's called shared security, because security is shared and the same for all applications that use this. Now, since Cosmos zones are separate blockchains and they have this issue that they don't have shared security, well, what happens if you took all these zones, you took all their blocks, and just posted them onto Celestia? Boom! Now you have easily and interoperable communication through IBC, and all of them share security. And this is essentially the promise of sharding. Like this is what sharding promised to give us: shared security for. It originally was 1024 shards, so 1024 separate blockchains. Then it got reduced to 64. Now it's 4. The latest Ethereum roadmap is to start with 4 shards. So, these are essentially 4 separate blockchains that run in parallel to each other, and they share security. But you can get this by having Cosmos zones that post their data to Celestia. Right? You get all the benefits out of sharding, but as you can see, the reason that the sharding roadmap for Ethereum has changed so much is because sharding is actually very complex. This protocol that I'm describing of just posting zone blocks onto Celestia is trivial. Like anyone can do it in their sleep, basically.
But Celestia itself is also a layer 1 kind of like zone, right?
I wouldn't call it. I guess you can call it a zone in and of itself, but it's intended to be used by having other zones post their data on top of it, rather than communicating with it directly. If that makes sense.
Yeah, so it would be more than like a hub, but it's just terminology, I think, in Cosmos. So I think it's not too.
No, the difference between a sidechain and layer 1 is perspective. There's no real functional difference.
So maybe to recap a little bit. So Celestia is, like we said, is a layer 1 technology in a sovereign blockchain that aims to be interoperable. I guess probably in the future you'll also implement IBC, if that makes sense at one point.
That's on the table. We'll see. Yeah. IBC. It's not that it's impossible to implement, but rather that it comes with certain caveats around how trusted is the bridge and stuff, and because it's not free to connecting to another zone as IBC is not free, right? It imposes certain validation requirements on all nodes. So it's up in the air whether and to what extent IBC will be implemented natively to Celestia, like the Celestia chain itself. But you can always connect via IBC to one of the applications zones built on top of Celestia.
All right, and so then the Celestia virtual machine makes it possible for other chains or applications to run on top of faster and simpler, right? Can you talk a little bit maybe about how Celestia scales? Because I guess if there's going to be a bunch of transactions and, or a bunch of like applications running on Celestia, at one point it could become congested, right?
Yeah, so all blockchains, except for one, have some sort of finite capacity based on the resource. Actually, no, except for two. One of them being Celestia, have some finite capacity based on the resource requirements of an end user full node. For instance, Bitcoin is limited to 1 megabyte to 4 megabytes per second, really. 1 megabyte for legacy nodes, but 4 megabytes per block. Bitcoin is limited to 4 megabytes per block because they target, like the Bitcoin community and the ecosystem is targeted. I want to run my full node on a Raspberry Pi, so I can fully validate the Bitcoin blockchain to make sure that the miners aren't stealing money and they aren't just printing a trillion Bitcoin out of nowhere, right? And you need this for this notion of self-sovereignty and sovereign money and sovereign applications. Is you want to know yourself without trusting any third party that the blockchain is like everything in the blockchain is valid. To do that, you have to validate it, right? There's not really any other way. There's some things you can do with fraud proofs and stuff, but for Bitcoin, for instance, you have to run a full node. Similarly to Ethereum, they say, okay, maybe not a Raspberry Pi, but maybe a more expensive computer, like a decent grade laptop with a good SSD, you can run an Ethereum full node, right? There's one blockchain actually that doesn't. And then within for these given hardware requirements for this cost to run a full node, that essentially constrains how many transactions per second you can have, how much gas limit you can have for Ethereum, how the block size in Bitcoin. Like fundamentally, if you take a piece of hardware, you run some benchmarks, its capacity for processing things is finite, and from that finite bound, you can then compute transactions per second, some transactions per second. That's essentially how it is. There's only one blockchain that does not do this, and that blockchain is actually Solana. The Solana team has said that they, no matter how expensive it is to run a full node, they will increase the cost to run a full node potentially until it's just like until it takes a supercomputer to run Solana, so that they will always have more capacity than demand, so transactions will always be cheap. I don't necessarily agree with this direction, but they're the only blockchain who has done this. Every other blockchain says, okay, we'll target a cost to run a full node, therefore a capacity is finite. If supply hits capacity, then a fee market emerges and transaction fees explode, right? So the only thing that a blockchain can guarantee you, other than Solana, of course, the only thing a blockchain can guarantee you is that it'll guarantee you a capacity. It will not guarantee cheap fees, because as soon as the capacity is hit, a fee market will emerge and transaction fees will explode, no matter what. It doesn't matter what blockchain that is. It doesn't matter if it's Celestia. It doesn't matter if it's ETH2. It doesn't matter if it's your favorite rollup of the week. All of them have some finite capacity, and once that capacity is hit, a fee market will emerge. They cannot guarantee cheap fees. The only blockchain that can guarantee you cheap fees, if that's really what you want, is Solana, because Solana has guaranteed fees will always be cheap. Capacity will always be greater than supply, no matter the cost to run a full node. They don't care. They don't care about the cost. Fees will always be cheap. So if that's really your priority, place your bets accordingly. If you value decentralization, as we know in the blockchain space, where everyone has this notion of self-sovereignty, where they can run a full node, the only thing any other blockchain can guarantee is capacity. Okay, so how does Celestia guarantee its capacity, and is its capacity greater than, for instance, Bitcoin or Ethereum? And why does it have potentially a greater capacity, right? That's essentially the follow-on question, right?
Mm-hmm.
Okay, so Celestia, so looping back to this notion of we want users to be able to run a full node of the system to validate that the system is in fact valid, right? So Celestia, since blocks don't actually execute the transactions, you don't actually have to. Since they don't execute the transactions, you don't necessarily have to fully download the block and then execute every single bit and byte in the block to execute everything. You only have to download the full block. But can you do better? The answer is yes. Because it turns out you can verify that a block is available to the whole world. And by available, I don't mean that you can download it at any point arbitrarily in the future. That's more like retrievability. Available just means it was published to the internet, and under the assumption the internet never forgets, then you'll be able to retrieve it. But really, you just want some attestation, some notion that it was published to the internet, and that if the internet collaborates, they can reconstruct this piece of data. So it turns out you can verify that statement. You can verify that some piece of data is available without fully downloading it. So we've gone from having to fully download and execute a block to just fully downloading a block. So by removing execution, you now get more throughput essentially for just downloading data, because your node is not executing transactions, it's just downloading data. So it can download more data in the same amount of resources, right? So we're getting scalability one there. The second thing is that you don't actually have to download all the data. It turns out you only have to download a portion of the data, and specifically you have to download a square root amount of the data. So let's say you had 10,000 pieces, 10,000 chunks in your block. You'd only have to download 100 of them, which is amazing, right? Imagine having to the square root of something is like that's a credible scaling factor, right? Like I said, from 10,000 down to 100, right? It's like it's out of this world, the scaling factor. And that's sufficient for you to verify the availability of block through a process that we call data availability sampling. It used to be called data availability proofs, but due to various technical reasons that proofs is a bit imprecise of a language, so we've been using data availability sampling for the past little while to describe this process. So now we have gone from a node has to both download and execute a block to a node just has to download. Now we've gone from that to a node doesn't even have to download the full block, they only have to download the square root of the block. Now you're getting like absurd scalability, where nodes in the Celestia network, and the capacity guaranteed by the Celestia network is like the square of like 10x, potentially 100x of what you can get on contemporary blockchains that couple together execution and data availability. And this notion of separating these different concepts is this notion of modularity. So traditional monolithic blockchains will execute transactions and order them all together at once in a way that's coupled, that you can't separate. These are things like Ethereum and Solana and Bitcoin and so on. And modular blockchains, like Celestia, is the data availability layer of a modular blockchain stack, because a single blockchain on its own isn't really modular. It's just it's a component of a modular blockchain stack. Celestia being the data availability module of a modular blockchain stack, by specializing these things, where you have, for instance, Celestia for massively scalable data availability throughput while preserving decentralization. It's the only blockchain in the world that can do this. And then on the execution side, you can have an execution layer, or potentially many, on top of the scalable data availability layer. And each of them is highly specialized by teams that really specialize only in execution. They don't know anything about consensus protocols, because the consensus is hard. They don't know anything about data availability sampling, because that's complicated, or anything about networks. They just design a really damn amazing virtual machine. And you can see this from the likes of Aztec. Most recently, they're talking about privacy preserving ZK Rollup. That's entirely execution. There's no consensus. Starkware is building good stuff with Cairo, which is essentially like a CPU and a Stark, so you can write arbitrary programs. There's no consensus there. It's purely just execution layer. Right? You have ZK Sync, which is doing ZK EVM. You have Arbitrum and Optimism, which are going for EVM equivalent optimistic rollups. And last but not least, you have the underdog Fuel, which is building the Fuel v2 protocol, which I'll show now, which is essentially going to be a next generation virtual machine that will allow you to have the ease and flexibility of the EVM, but will allow you to have a throughput similar to Solana while maintaining decentralization by leveraging parallelism, which is something that no other Rollup project is leveraging. So if you have an 8-core CPU, just off of that and no other optimizations, of which there are many, you're getting like an 8x performance increase. When you compound it with other optimizations, you're easily getting like a 100x performance increase over execution environments like the EVM. So if anyone out there is interested in rollups, I highly suggest you check out what Fuel is going to release with Fuel v2. Let's say keep your eyes peeled for an announcement in 2 weeks.
I think we can talk a little bit more about rollups in just a second. But just to also summarize, because also I have to like wrap my head around, I think after this, there's a lot I have to read and learn and research to fully understand. But if I fully understand, through data availability sampling, Celestia ensures to always have enough block space to process all these applications that are running. Would that be a fair statement to make? Or
no. So Celestia does not guarantee that there will always be more capacity of block space for data availability throughput than supply. It doesn't guarantee that. What it does guarantee, however, is that the capacity it does provide will be much, much, much greater than what you get out of contemporary blockchains.
Okay.
That's the only guarantee it can provide. Now, if it turns out that there's so much demand for this finite supply, then a fee market will inevitably emerge, and that's how it is. Like I said, no blockchain can guarantee that capacity will always exceed demand, except for Solana, because Solana has guaranteed that there is no guarantee for the cost to run a full node. With Celestia, we want end users to be able to run a full node and to run a secure light client and perform this data availability sampling. We are actually the blockchain that targets the cheapest hardware requirements for you to be able to enter and contribute security into the system. You can perform data availability sampling essentially on your phone. And this isn't just something that you do for yourself. This actually contributes back security to the network.
Yeah, I think one article or one blog post that recently came out that actually sounds exactly like kind of like the roadmap that you guys have at Celestia is Vitalik's Endgame post, right? He talked a lot about actually data availability sampling. I think it's called exactly with the same terminology.
It's the same technique, yes.
Yeah, and also about rollups and all these things. So maybe I'm sure you read this paper. Can you maybe share your views on that, and also what do you think? Is he basically describing Celestia there, or?
I had a recent Twitter Spaces with Angela from ZK Sync and Daniel from Arbitrum just a few weeks ago. So if anyone here happened to listen to that, then you'll probably know my answer. But it essentially describes a more circuitous route to get a worse version of Celestia, in my opinion. The reason being is that the reason shards are secure, because like I said, as I gave some context before, shards are just blockchains. Right? Each shard is a blockchain. And the reason that they share security is because they're all essentially on a common data availability layer. And the way you accomplish this in a sharded thing is that every node in E2 will perform data availability sampling for every shard. But because the scalability factor is square root of n, it means that you actually get the best benefit out of the square root of n if n is large, right? Like imagine if n is 1, the square root of 1 is 1, right? Okay, if we're being cute, you could say it's also I, but okay, that's or minus 1, sorry. So the square root of 1 is 1. The square root of 10,000 is 100. So you get the best scalability by having large blocks essentially, and instead of having many small blocks. And you can think of a Celestia block as essentially taking those 64 shard blocks that you get out of a single Ethereum beacon chain block and just making a big block out of it. So you reduce the overhead of data availability sampling because you run it once per block instead of 64 smaller times per block, which would have more overhead. And that's what makes sharding secure. So as long as you have that, you don't actually need sharding. And Vitalik describes in his Endgame post that a big blockchain where it's expensive for block producers to produce blocks, but it's cheap for validators, not validators, it's cheap for end users to run full nodes and to verify that the block producers are behaving honestly. That is essentially the fundamental thing that from the beginning, Tendermint and Celestia have been built around. It's Vitalik realizing this years later. And the entirety of E2 hasn't been built around this idea. The entirety of E2 has been built around, we want to make it very cheap for someone to be a block producer in E2, but those block producers aren't actually even guaranteed to produce valid blocks. Little known fact, there's this thing called surround votes, and surround in the Gasper protocol, in the proof of stake protocol that E2 uses. There's this thing called surround votes, and if someone does a surround vote, then they're supposed to be penalized. But it turns out that detecting a surround vote is a big O of n squared operation, not square root of n, but n squared, which means if you have like 100, if your n is 100, now you're doing 10,000 operations. And it turns out that n isn't 100, and it's not 10,000, but it's on the order of several million, potentially in the worst case. And if you don't actually detect these things, you're not actually contributing to the security of the ETH2, because someone could make a surround vote. In the worst case scenario, potentially it might take a huge amount of resources to detect this. And they only have a handful of nodes potentially running these surround vote detectors, because their philosophy hasn't been from the beginning, make block production expensive, but make verification that the block producers are honest as cheap as possible. Celestia has been designed from the beginning to make verification, to hold the block producers accountable as cheap as possible, so that the worst case cost that someone must pay to hold the block producers accountable, we minimize that worst case cost. E2 hasn't been built with this philosophy, and that's why it has things like sharding, and that's why it has a huge number of validators, which isn't really relevant because by power law or distribution, to like the Nakamoto consensus for the E2 consensus, the E2 staking pool is like, I don't know, 5, 6, 7 voting pools, validator pools control 2/3 of the stake. Why do we need a million validators? It doesn't actually help. So essentially, it's a circuitous route to getting a worse version of Celestia, and potentially it could be years later. The roadmap for Endgame is essentially start with 4 shards, but no data availability sampling. And Daniel from Arbitrum was very critical of this approach, that he said in a Twitter Spaces, because without data availability sampling, shards aren't secure, or it means you require every full node in the Ethereum network to fully validate every shard, and that's not scaling, that's just a block size increase. Then they want to move from 4 shards, I don't know, 16, then 64. Then, after all that, implement data availability sampling. So Celestia has working data availability sampling with multiple nodes. We released a DevNet earlier last month, I think. So it's been out for a month already. Like, we have working data availability sampling. DevNet, we have external contributors right now who are running nodes on our DevNet. And we're planning to, launch a testnet in a matter of a few months. So this is progressing very rapidly. While Ethereum too has, data availability sampling, which is the thing you need to make this secure fully, to like actually make it secure. They have it all the way at the end of the roadmap. So knowing the pace of Ethereum development, this could be. People have been saying optimistically 2023, but this is like, potentially 3-4 years, maybe more down the line.
And one thing that was just announced is a project in collaboration with the Evmos team called Cevmos, which is a specialized settlement layer for EVM rollups that is making use of your data availability layer. So maybe you can share about Cevmos, what it is, what it does, and also kind of like what's the current stage for, also in terms of like use cases, what can we expect that we can do with Cevmos when it's fully live?
Sure. So Cevmos is, I think, Celestia Evmos, where Evmos is what, EVM OS, something like that. I keep in my head I always say EVM OS. The Evmos name never really grew on me. But anyways, so Cevmos is Evmos on Celestia. It's essentially the Evmos chain, really, but it runs on Celestia instead of being its own zone, its own layer 1 essentially. It runs on top of Celestia as a rollup. Like, these applications on top of Celestia are fundamentally the same as rollups on Ethereum. They're rollups, right? They rollups share security with each other. So it's a rollup, and it runs the EVM. And you're correct that it's called a settlement layer, because a settlement layer is where disputes are arbitrated essentially, and where you can have secure communication, essentially between multiple domains. So one thing you could do on top of Cevmos is run, for instance, an Arbitrum rollup, or you could run an Optimism rollup, or you could run a Fuel rollup, or you could run a Starkwire rollup, or you could run any number of rollups. These are just names I'm pulling. There's the names I'm pulling up randomly because there's rollups on Ethereum, right? You could just fork their code if you really wanted to and just run them on top of Cevmos, because Cevmos is an EVM. It's an EVM the same as Ethereum. It's exactly EVM equivalent. So anyone in the world could just take a rollup that exists on Ethereum and add it on top of the settlement layer rollup. So now you have kind of the 3-layer structure, where you have Celestia on the bottom, you have a settlement rollup, Cevmos, and then you have potentially a huge number of these execution rollups. These ones here do actual execution. And the thing that we're doing here that's different than just a regular EVM fork is the Cevmos settlement rollup is specifically designed only for settlement. So we're not going to allow, I shouldn't say we, whenever it launches, because this is a project built in collaboration with several teams. But the trick is Cevmos won't allow any arbitrary smart contract to execute on it, such as Uniswap or Aave, Maker, whatever, DAOs. It won't allow you to execute smart contracts natively. It will only allow you to execute the disputes and the verification of validity proofs and stuff that you need for rollup and inter-rollup communication. So because of that, it's EVM compatible, so you can exactly fork your rollup contracts from Ethereum to Cevmos. So you don't have to make any changes to those, but it'll be potentially much more scalable than Ethereum because we limit what you can execute in it to only some small number of settlement contracts, some small number of rollup contracts, essentially. And if you go back all the way to why is Ethereum slow, what's the problems with it, it's the EVM, right? But it's not just the EVM, it's specifically the EVM for Ethereum, because the EVM for Ethereum has 150 gigabytes of state. Like the entire state tree of account balances and token balances and all this other stuff is 150 gigabytes. In addition to that, you can execute any arbitrary Turing complete code, which could be very expensive over this large state. But if we start from scratch and say, okay, we start with an empty state, and even though it's technically Turing complete, we limit it to just doing some settlement stuff. Like we limit what it can do within this Turing complete space. Now suddenly you can potentially have a much higher throughput rollup on the same hardware requirements. This much higher throughput execution environment. So that's essentially the TLDR of what Cevmos is going to be. It's a specialized for settlement rollup that's going to run on Celestia that other execution rollups that actually execute applications can attach to and use for settlement. Does that make sense?
Yes, and I think what would be nice to hear also now in that context is a little bit of a timeline where you guys stand right now. You just mentioned that the DevNet just went live earlier this month, and then Cevmos was just announced. So maybe you can give some insights where you guys currently stand, what you're mostly busy with right now, and what the most important challenges are towards kind of like the road to the mainnet, which I think is scheduled to go live sometime in Q2 next year. Is that correct?
Q2 might be a bit optimistic, but it's sometime next year for sure.
All right.
If it was up to me, we'd have launched this year, but it's not up to me.
Yeah,
but anyways, yeah. So in terms of timeline, yep, that sounds about reasonable. Q2 next year. I mean, this is just like off the top of my head. There's a lot of work that needs to be done in terms of building out infrastructure and tooling and stuff. So sometime next year for sure. So in terms of our initiative, in terms of the initiatives that are being built, is we have the Cevmos chain, right? Work has kind of been started on this. It's making very good progress, along with integrating like several example execution rollups on top of it, and maybe minor modifications if any is needed at all. And we're also working on a separate initiative, which is called the Quantum Gravity Bridge. And the Quantum Gravity Bridge is a relay, essentially, from Celestia to an EVM compatible chain such as Ethereum. And it essentially allows you to relay attestations that data is available on Celestia, some Merkle root, essentially. Some Merkle root that contains a bunch of leaves. Some Merkle root of data, not that the Merkle root is available, but the leaves behind the Merkle root are available on Celestia. And it attests to this on the EVM chain. For example, Ethereum. Now, what's the purpose of this relay? The purpose of this relay is if you're building a rollup, for instance, and you're on your favorite EVM compatible chain like Ethereum or BSC or Avalanche, and you say, okay, I'm a rollup here. I don't know if I want to take the plunge to deploy my code onto Cevmos, right? Because maybe it requires, maybe a small number of changes, hopefully none, but maybe a small number, or, maybe it requires a bit of, peer-to-peer, the P2P networking refactoring. Okay, so maybe I don't want to take that leap just yet, but I do want to benefit from the fact that Celestia has a huge shitload amount of scalable data availability throughput, which your favorite Ethereum blockchain does not have, right? You want to benefit from this if you're a rollup project, because data on Ethereum is 16 gas per byte, and that's hella expensive. So what you do? Well, you say, okay, why don't I use this relay, this quantum gravity bridge relay, which attests to the fact that data is available on Celestia, and therefore I can use Ethereum or your favorite EVM chain for settlement as opposed to Cevmos, but you're using the attestation to implicitly use Celestia for data availability. And this is the beauty of the blockchain modular stack. The modular blockchain stack is that you have fundamentally three components: data availability, settlement, and execution. With Celestia and Cevmos, we're building all three layers of the stack integrated, but we're also building tooling and infrastructure so that if you don't want to use Cevmos for settlement, then you can actually use Ethereum for settlement, for instance. So Celestia for data availability, Ethereum for settlement, and then you roll up on top of Ethereum that through the relay uses Celestia for data availability. So you can get the benefits of Celestia without necessarily having to dive entirely within the ecosystem. You can still remain within the Ethereum ecosystem and benefit from it.
That sounds very, very interesting and exciting. I'll definitely have to do my homework on all these things to fully understand, because again, I don't have a technical background. So for me, always to like wrap my head around these things is a bit complicated. But still, I think the point is that Celestia will bring more modularity, or I don't know what the term would be, but kind of like fragmentizes those things into smaller parts so that you have more flexibility to build and customize your chain. That's, I think, a very exciting plan that you guys have. Before we get into some of the questions here, please, everybody who's listening right now, drop your questions. If you have any for John or anything around Celestia or his views on crypto as a whole. Is there anything that you would like to share before we get into questions, or should we move on to?
Well, I guess we can move on. We can move on to questions. How are we doing on time?
Yeah, we're actually already at an hour. I mean, time is flying.
We are actually. I can go a few minutes over. I technically have another call that starts now, but I can go maybe a few minutes over if
no, it's fine. We can do it real quick. I think everybody's also kind of like just learning and listening from you.
I apologize if it was too technical. I think I
no, that's totally fine. I mean, I had a lot of interviews in the past where it was more about journal things, and also a lot about the crypto space, IBC, and very Cosmos focused. So I think today was very educational about the broader kind of like blockchain kind of like foundations and fundamentals. So that was really helpful, I guess. Jobber is saying Celestia is a game changer. Yeah.
Not a question. I agree, but it's not a question.
It's not a question. Yeah.
Head exploding, yes. That's how I felt too when I read the Lazy Ledger white paper back in the day.
Mike is asking, will Celestia light node be limited by Tendermint max validator count?
Yes. So Tendermint's max validator count might be somewhere between 100 and 200. So Celestia's consensus protocol is Tendermint, so it'll also be similarly limited. This is fundamentally not a problem, and Vitalik described why in the Endgame post. It's that it doesn't matter how expensive it is to run a validator. It doesn't even matter how many there are. In fact, you could run a chain with just one validator in the happy case, in the happy path. As long as you had the ability to hard fork and socially coordinate, that validator can't do anything bad. Even if it was just one. Even if you had, for instance, Binance Smart Chain that people say it's ran by just Binance, but it's like, as long as the node client is open source, anyone in the world could just hard fork Binance Smart Chain, remove all of CZ's money, and just install their own validator set. Maybe you like the ETH2 researchers, maybe you like the Ethereum core developers that just got gifted $153 million in validators, and not cash, that they now have to run infrastructure for, which is not free. Maybe you like these guys, and okay, you install them as the validator set. You can do that as long as the node software is open source, and as long as the data behind the blocks is available. So the number of validators is essentially irrelevant, and Vitalik agrees with this in his Endgame post, because you can always hard fork them out. You can always socially coordinate to hard fork them out. They can't do anything bad. So yes, Celestia is using Tendermint. Tendermint is limited to 100 to 200, but the number of validators doesn't actually matter for anything.
And OnePlay5 is saying, good interviews, guys, loving it. Thank you for the feedback. We appreciate that.
Thank you as well. I appreciate that.
Shreyash Patodia is asking, if Celestia as a chain is compromised, then the blockchains are down to their own security, right?
That's a tricky question. So Compromised is in a proof of stake setting, let's say. Compromise would mean the chain is unrecoverable from. But generally speaking, the threat model in proof of stake is you can recover from attacks, but attacks will cost the attacker billions of dollars potentially in slashed stake. This is the whole reason that proof of stake is so secure, because you can enforce penalties, not just rewards. Right? It derives security from our ability to enforce penalties. Eric Wall, a good friend of mine, has a post about this, how, on Medium that he posted maybe 2 years back or something, that proof of stake can in fact be cheaper than proof of work because of this notion. So the if here, the antecedent here does a lot of heavy lifting, because in a proof of stake setting, the chain should never be compromised because you can always recover and penalize the attacker potentially billions of dollars. Now you're saying, what happens if the attacker is a nation state actor that can throw like trillions of dollars or quadrillions of dollars, who the hell knows, right? And just keep DDoSing your chain and keep slashing it every single time you try to boot it up, and just take your full node operators and throw them in prison even. That could happen, but then you have bigger problems. Like, then they wouldn't attack Celestia only, they would also attack all the subchains and attack Ethereum and Bitcoin and everything in between. So you're not really going to get into a scenario in a proof of stake system where the chain can be compromised, really, is how I would answer that.
All right. Andy's stating it was really clear. Thank you, John.
Thank you.
Kinome is asking, in Celestia, how can censorship be avoided if block production is left to rollups? Is it just a threat of a fork emerging?
So there's two ways blocks can be produced. So Celestia blocks are produced by the Celestia validator set, and if the Celestia validator set misbehaves, like I said, you just coordinate socially, hard fork them out, billions of dollars get slashed, and the chain resumes. It's not like they stole anyone's money. They just lost billions of dollars for a minor hiccup in the chain. Okay, it's down for an hour, and then billions of dollars gets lost, and we resume. And the attacker shouldn't do that again, or a different attacker should learn the lesson, right? So that's for Celestia blocks. But there's also rollup blocks, because rollups have to make blocks and post them inside the Celestia blocks. And how those blocks are produced is orthogonal to Celestia, because Celestia doesn't care. It just sees zeros and ones, and it says, okay, I'll include this in my block. I don't care what they are, right? So that's orthogonal, and that means rollups and applications on top of Celestia have to have their own mechanism for guaranteeing censorship resistance somehow. Now, what's important is the ability to produce new blocks isn't inherently the same thing as a full-blown consensus protocol. Right? The ability to produce new blocks is really just some leader selection protocol, which is only one subset of the full consensus protocol. Now, one nice thing about Celestia, and this is something that Celestia does uniquely, is applications on top of Celestia, since the logic of the application is actually entirely on the application side, and Celestia doesn't know what it is, you can actually hard fork the application without affecting Celestia, right? Because you just upgrade the node software. Like let's say you have a Bitcoin rollup, right? You have a Bitcoin rollup that's running on top of Celestia. Then you want to implement the Taproot soft fork because you haven't implemented it yet. Okay, so you just implement the soft fork, and now you have the same blocks that are posted to Celestia, but now your full node software for the application, for this Bitcoin application, is now executing the blocks differently. It's now executing them with Taproot logic, the Bitcoin blocks. So you can actually have hard and soft forks for applications that run on top of Celestia, and this includes potentially hard forking out the leader selection mechanism and the leaders of the rollup. So I hope that generally answers your question, is that for any blockchain, the real way you avoid attacks by the validator set is the ability to hard fork. And Celestia, of course, as a layer 1, has the ability to hard fork. But rollups also, so rollups that are built natively on top of Celestia also have the ability to fork. And this is the notion of self-sovereignty, or just sovereignty in general. Applications on top of Ethereum, for instance, like Uniswap cannot hard fork. They can have an on-chain governance mechanism, but that on-chain governance might be captured by rich VCs who own 2/3 of the 51% of the coin stake. And I think the Uniswap DAO, there was some things going on where someone came in, some VC came in and helped some college friends or something, some nepotism going on. Uniswap can't hard fork. A rollup chain on top of Celestia can hard fork to change its rules however it wants without affecting Celestia. So it's sovereign, similar to a Cosmos zone.
Yeah, I think that answers the question. So thanks for clarifying that. Maybe we can wrap it up with the last question, a very quick one from Jane, whether Celestia will have staking in the protocol.
Yeah, so Celestia uses Tendermint proof of stake as its consensus protocol. This means there must be some staking mechanism, which means there must be some coin. So Celestia will have its own separate new coin. It is not available for public purchase yet. So if you see anyone selling any Celestia coin, they're scamming you.
Is there already any plans in terms of rolling it out, or I don't know, some kind of like decentralized launch or bootstrapping event or anything like that?
I can't really speak to any plans.
All right, easy. All right, X1K is saying, thanks for the spontaneous interview. We'll watch this again maybe a few times, and I agree. I will do the same. And I also thank you, John, for jumping on so spontaneously and so quickly. It's been an honor to speak to you and also to meet you for the first time. So yeah, I will definitely keep track of all this. Probably in the future also have maybe Nick or Mustafa or Ismail on to see what's progressing and how things evolve. So yeah, thanks for your time, and we'll hopefully keep in touch.
Absolutely. Thanks for having me. It was a pleasure to be on.